it is you want to do.
Well, hey, listen, Chief. I've taken the math also plenty of times, and I know I'm never going to need this math again.
What is it that you want to do?
I'm going to be a fireman.
A fireman?
Henry 39, we need you to respond. An overturned semi with about half a ton of 222 chickens involved.
Henry 39, copy. William Roberts.
What's going on?
I am going to have to drop you off.
What about Safeway?
Yo, Sparky!
Thanks.
Sparky, he's all yours.
So, that officer over there was trying to tell me that even firemen use math. I like your fur. I'm gonna go now.
Sparky, you brought us another visitor.
Oh.
Hi, Travis. I'm Kyle Ohashi with the Kent Fire Department.
Hi, it's nice to meet you. So I hear firemen use math. Is that right?
Firemen use math. Well, we do. Why don't you come with me?
Okay.
Firemen do use math, and actually,
actually,
we're called firefighters now because we have both women and men in the fire service. So come this way, and we'll talk about it.
Okay. I forgot my ride. Got it.
Okay, Travis, let me give you an example of how firefighters use math. When we go to a fire, the pump operator at the fire engine has to be able to calculate its friction loss so that he gets the proper amount of water from the engine to the end of the hose so that the firefighters that are there can fight the fire effectively and safely.
Huh. Can I maybe get an example of that?
Sure, I'll tell you what, let's go out to the engine. I'll show you the pump panel and I can explain it further.
All right.
All right.
So this is the pump panel?
Exactly. And hopefully this is going to make it a little bit easier for you to understand what we're talking about when it comes to algebra. These hoses are 200 feet long, and the pump operator has to know how much pressure to pump this pump at in order to get the firefighters the proper amount of pressure to the firefighters in the burning building in a safe manner. And we have what's called friction loss. And we get about 40 pounds of friction loss for every 100 feet of hose. So these hoses are 200 feet long. So there's going to be about 80 pounds of friction loss. And so the firefighters have to make sure that they pump this panel with enough pressure so that the firefighters at the other end get the proper amount of pressure and water in order to fight the fire as quickly, as safely, and efficiently as they can.
Well, why do you have to use math? Can't you just turn the nozzle and you're good?
Well, that would work to a certain degree, but in order to do it so that they're safe and they can be efficient and as quick as possible, you have to give them the proper amount of pressure. So we know through field hydraulics that there's 40 pounds of friction loss from every 100 feet of hose that's stretched out. So when this hose is stretched out 200 feet, they have to have about 180 pounds of pressure in order to get the proper amount of water. And that's all part of that field hydraulics that a pump operator has to keep in his head. So there's a certain amount of algebra that you have to know in order to do this safely.
So, do you use other math besides algebra?
Absolutely. One of the things that we use is geometry. And we're down here at our hose tower right now, and we do a lot of training in this. And one of the things we use are ladders. And ladders are used for several different things in the fire service. One of the things is so that our firefighters can get into buildings safely. Another thing, obviously, is so that we can get people out safely. But one of the most important aspects of using a ladder is making sure it's at the proper angle. Because if it's too steep, it becomes very wobbly and people can get hurt, especially civilians trying to come out. And if it's too flat, it makes it very difficult to get in. And again, the ladder becomes unstable because it can slide out. So what we do is we look at ladders and we try to set them up at a 70-degree angle. So if you look at 90 degrees being vertical, we go about 20 degrees off of that. And that creates an angle that gives the ladder a lot of stability, and it doesn't allow it to either slide out flat or topple over because it's too tall.
Yeah, that really makes sense. I never thought of it like that.
So Travis, now that we've shown you a couple examples of how firefighters use math, do you have a better understanding now?
Well, this entire math thing wasn't even useful until you became a firefighter, right?
Well, you know, I've actually done a lot of different jobs. I've been a bartender, I used to manage restaurants, and I used to be a delivery driver for UPS, and all of those jobs use math.
Well, how am I supposed to get a job when all the jobs use math? I just can't handle that.
You know, there's a lot of things you can do. While you're in school, study hard with your math. When you're outside of school, there's a lot of things you can do as well. When you're presented with a math problem, try doing that math problem in your head or writing it down on paper, but don't use a calculator to do it.
Wow, thank you, Captain Ohashi. I mean, this has just been an eye-opening experience. I mean, before all this, I never thought math had to do with my life at all, but now I'm starting to think about my future
And all of these things that have to do with math. And now I can apply them to my life, and I can do a better job.
Hey guys, dinner's ready.
Great.
Whoa, where are you going?
Oh, why don't you come with me, Travis? I'll show you another example of how firefighters use math.
Alright.
So Travis, I'm going to show you another example of how firefighters use math. Art, what's up?
Dinner was $24 for the groceries.
There are 6 firefighters that work at the station, so how much is it going to cost each firefighter for dinner?
Well, if that was $24, and then 6 firefighters. You carry the 6, and
It comes to $4 per firefighter, Travis.
right. I was just about to say that. So can I get in on this, or?
Do you have $4?
I have 80 cents.
There's 80 cents worth.
Thank you. This looks delicious. Oh, hey, I gotta go. I just forgot